Okay, the last thing I want to demonstrate is some of the testing that we've done for achieving qualification. And this is a test case that you would never write yourself, and because it's sort of a silly test case, we have a lot of real code that we run through CodePeer every night. We have thousands of tests. Essentially, every piece of code in our bug database, which isn't necessarily a CodePeer bug, but any bug that's ever been reported against the compiler, as well as files that we create for enhancements and so on, all of that code is run through CodePeer every night. So we do a tremendous amount of testing on real code. But for the purpose of doing validation, it's necessary to test on a more systematic sort of testing. And so what we're going to do now is we're going to analyze one of these sort of artificial tests, but it's one of a large set of artificial tests that are designed to exercise essentially every feature of CodePeer. Because to achieve tool qualification, which is what this is all for, you have to be very systematic. You have to show that for every kind of test that CodePeer claims to do, you have an example that shows that it does it when it's supposed to and it doesn't do it when it's not supposed to. So we're going to drill down now. So we have some highs here, some mediums, and so on. And these tests are all checked mechanically every night as part of our qualification kit testing. And let's look at some of these tests. Okay, so here we have, again, tests that you would never write yourself, but this is declaring a matrix. What is a matrix? It's a two-dimensional array of integers. It's initializing that matrix with an aggregate where the choice part of the aggregate is an expression which involves a divide by zero. And CodePeer has determined that this value is zero by a series of analysis steps, looking at the declaration of 0, 1, and so on. And this is a very odd place to worry about a divide by zero, but this just verifies that CodePeer worries about divide by zero wherever it might occur. Similarly, here we check whether you're doing a modulus with a zero, a mod operator with a zero modulus. Again, not a common place to worry about using modulus, but CodePeer wants to be sure that we're catching divide by zero wherever it might occur. So again, this is sort of a silly test case, you might say, but we really don't want to leave any holes. So we want to, be very thorough, and that's what's going on here. Okay, so let's go to a slightly more interesting test case. There we go. Let's look at this one. Okay, so this one, now we're doing the divide by zero in a slightly more normal place, that is in the actual expression that's being used to initialize the matrix. And again here, we have a divide by zero, we have mod by zero, and rem by zero. And we're checking all three of these and making certain that CodePeer provides the appropriate error message. So if we look at this one, we get index check fails here. We also have divide by zero. Here we also have another divide by zero in line 17. And finally, in line 20, we have another divide by zero. So CodePeer is really checking all of these. It's also checking other things. So for example, we had an index check failure here. Well, why is the index check failure? Well, because we've declared a matrix whose bounds are 0 to 1,000 and 1 to 500. And then we've declared an array where we have an index range of only 1 going to this, and this bounds are 42 to 666. So that does not match 1 to 500 any way you slice it, or any way you slide it for that matter. Ada allows these, as long as it's the correct number of values, it's okay if the indices are off, but here it's not even the correct number of values. It's significantly more. It's 624 values or so, 623, I suppose, 625, and this is expecting 500. Anyway, so this is just illustrating the kinds of picky tests that we write to check all sorts of places for divide by zero and a number of other problems such as array out of bounds and so on. And there are large numbers of these tests. I could open many other projects. I was just showing you a few of them, but this whole directory is full of different tests with slightly different, let's say 64-bit integer versus 32-bit integer, or other kinds of combinations. We really want to try all combinations of all interesting checks and so on. So that's what tool qualification requires. And we provide you with the tool qualification material if you buy the qualification kit, and that allows you to include it in your information that you provide to your customer as far as proof that you're using tools that have run through a very systematic qualification test.